Hi, this is lesson 4.2. We're going to talk about graphing quadratic functions, equations, and we're going to use vertex form and intercept form. So we've already done some graphing, but now we're going to look at these equations in two separate forms. So let's just start with a little intro here. We're going to graph this function. We're going to start by finding the vertex. And remember, actually, before we find the vertex, I like to find the axis. So to use the axis, we find x equals the opposite of b over 2a. This is the axis of symmetry. B here is 2, so the opposite of 2 is negative 2. Over 2a is negative 1. So this is really negative 2 over negative 2, which is 1. So our axis of symmetry is the line x equals 1. And I can draw that right on my graph right here. And I do my axis of symmetry as a dotted line again. I'll label it x equals 1. So we know our vertex is right on that axis of symmetry. So I'll plug 1 in for the x coordinate of my vertex. And then to find the y, I plug 1 into the equation. So it's the opposite of 1 squared plus 2 times 1 minus 3. And if you plug that into your calculator and simplify, you'll get negative 2. So we know our vertex is 1, negative 2. So I'll put that on my graph. So 1, negative 2 is right here. So there's my vertex. Looking at my equation, notice how this is negative, so that tells me my graph is going to open down. So I can expect my graph to look something like this. So my y-intercept is the next point, and we talked yesterday, or in the last video as well, about our y-intercept, and that's c right here. So our y-intercept is going to be at negative 3. So my y-intercept is going to be right here at negative 3, and this is the point 0, negative 3. And if I reflect that across the graph, there's another point right here. And we know our vertex is our maximum. So we have a maximum value, and that's the point 1, negative 2. And so if I connect these points, there's my parabola. So let's talk about vertex form of quadratic. The vertex form of a quadratic looks like this. It's y equals a times the quantity x minus h squared plus k. This means that our parent function, y equals x squared, is translated either left or right. H units, okay, notice where h is right here. It's going to go in the opposite of what you would think. So if it's minus a number, you're going to go to the right. If it's plus the number, you're going to go to the left. So we should probably put a little note. It goes left if it's plus a number, and it goes right if it's minus a number. And then it also goes up or down k units, and that goes the way you would expect it. If it's plus k, it goes up. If it's minus k, it goes down. The vertex, when it's in vertex form, we can easily tell the vertex of our graph. It's the point h, k, and this is why it's called vertex form, because we can see our vertex real quick. Our axis of symmetry is x equals, and we know our axis of symmetry is the x value of our vertex, so it's x equals h. When a is greater than 0, our graph opens up, just like before, and if a is less than 0, our graph opens down. So this is some basics of vertex form. Let's look at a problem in vertex form now. I'll stop right there. So given our function, y equals 1/2 times the quantity x minus 1 squared minus 4, we're going to graph and answer the following. So the first thing we want to know is our vertex, and our vertex is hk. H is here, and k is here. And notice it's minus h. So my h is positive 1, my k is negative 4. So my vertex is the point 1, negative 4. So my axis is the line x equals 1. And if I graph that axis, x equals 1 will go right here on my graph. It's the line x equals 1. Let's also put our vertex on our graph, the point 1, negative 4. It'll be right here. There's my point 1, negative 4. And we want to graph it, but we need to find a couple more points. So let's figure out what it is when x equals 0, and then we can reflect it. And let's see what it is when x equals negative 1, and we can reflect that one. So I'm just going to quick make a table here. I want to figure it out when x is 0 and when x is negative 1. And if you plug this into the function, 1/2 times the quantity 0 minus 1 squared, and subtract 4, so that's all I'm doing is plugging 0 into there, I get negative 3.5. And if I plug negative 1 in there, I get negative 2. So I know negative 1, negative 2 is a point, and if I reflect that, that would come right here. And 0, negative 3.5 would be right here. If I reflect it, it'd be right here. So there's my graph. And it says describe the transformation. We know that our parent function starts here at 0, 0. And this, the vertex went to the right 1, and then it went down 1, 2, 3, 4. So we need to say that. We need to say right 1, and we need to say down 4. But we also need to look at whether it's a shrink or a stretch. And our parent function goes over 1, up 1 to get to the next point. Here I went over 1 and up only 1/2. So this is a shrink of 1/2. And notice this is where the 1/2 is. This will tell you what it is right here. So we have a shrink of 1/2. And again, notice our right 1 and our x-coordinate of our vertex is 1, down 4. Our x-coordinate of our y-coordinate of our vertex is negative 4. So let's look at this next problem right here. We're given a new function right here, and you should start being able to see things just by looking at the equation. Our vertex, remember, is hk, but it's going to be the opposite of this. So instead of positive 2, it's going to be negative 2. So our vertex is negative 2, 3. Our axis is the line x equals, and it's the x value of the vertex, so x equals negative 2. And let's draw that vertex and axis of symmetry right in here. X equals negative 2 would be right here. That's x equals negative 2. And my vertex, negative 2, 3, is right up here. And just by looking at my equation, I know this a is negative, so my graph should open down. And it's 3, negative 3. So remember up here we said there was a shrink of 1/2 when this was 1/2. So this tells us we're going to have a stretch of 3. And then this negative tells us it's going to go down. So I know that my graph is going to, instead of go over 1 and up 1, it's going to go over 1 and down. But instead of going down 1, it's going to go over 1 and down 3. So to go over 1 and down 3, I would end up right here. And then I would also end up right here. So there are 2 more points on my graph that I can tell just by looking at this equation. So to describe our transformation, we know that negative sign made it flip upside down, so we call that a reflect over the x-axis. Our graph was reflected by that negative sign. And we also know we had a stretch of 3. We don't say negative, we just say stretch of 3 because that negative sign was taken over when we said the reflection over the x-axis. And we also went left 2, and then we went up 3. You can tell all those things really just by looking at an equation in vertex form, which is why it's helpful. So let's flip the page over and look at the next side. And I forgot to draw this in here, so I need to draw my parabola in. There, we can't forget that. So now we're going to talk about intercept form of a quadratic. So the intercept form of a quadratic is y equals a times the quantity x minus p times the quantity x minus q. This means the x-intercepts of the parabola are at the points p0. Well, that should be a p. It doesn't really look like a p. Let me see if I can find my eraser. So they're at the point p0, p0, and q0. Those are my x-intercepts. Now the vertex is going to be halfway between the x-intercepts always. So to find the x value of the vertex, we do x equals, we just find the average, p plus q divided by 2. That allows us to find the x value of the vertex. So let's look at this next problem. Oops, I forgot to finish filling in that box here. The axis of symmetry is then x equals p plus q divided by 2. And if a is greater than 0, our graph opens up. When a is less than 0, our graph opens down. So looking at this next problem here that we want to do, given our function right here, now here's my a. Okay, this is my a right here, and it's negative, so that tells me right now my graph is going to open down. And right here, okay, these are my, this is really in factored form, okay, so we're going to find our intercepts using this, then we're going to graph and answer the following questions. So to find our intercepts, we have to figure out what can I put in here, what can I put in for x. Well, it's actually just going to be the opposite sign here. See how this is minus p? Opposite sign. Minus q, opposite sign. So here we have plus 1, so one of our intercepts is going to be negative 1, 0. And here we have minus 3, so the other one is going to be positive 3, 0. So we've got negative 1, 0, and positive 3, 0. Those are our intercepts. Now to find our axis of symmetry, we do x equals, we add our intercepts together and divide by 2. So negative 1 plus 3 is 2. 2 divided by 2 is 1. So our axis of symmetry is the line x equals 1. And our vertex we know is on that axis of symmetry. It's got an x value of 1. So to find y, I can say y equals the opposite of 1 plus 1. I'm plugging my 1 into my function, or to my equation, times the quantity 1 minus 3. So y equals the opposite of 2 times 1 minus 3 is negative 2. So negative 2 times negative 2 is positive 4. It's my y value of my vertex. So my vertex is the point 1, 4. Let's graph these right here. Oh, I forgot to put a parenthesis right here. My axis of symmetry is the line x equals 1. So x equals 1 is this line right here. Okay, that's my axis of symmetry. My intercepts are negative 1, 0 and 3, 0. And those should be the same distance away. And if you notice how I do it when I do this, they are the same distance away from the middle. And then my vertex is the point 1, 4, which is right here. So I've got 3 nice points on there. I'm just going to connect them. And there's my parabola. Let's try another one. Let's look at this example 4 right here. So again, we just want to look at it. First of all, let's look at our A to tell if our graph is going to open up or down. So looking right here, it's positive 4, so we know our graph should open up. And our intercepts, remember, are going to be the opposite of these. So this is minus 2, so one is going to be positive 2, 0. This is positive 2, so one is going to be negative 2, 0. So our intercepts are at 2, 0 and negative 2, 0. I'll just plot those right now. 2, 0 is right here. Negative 2, 0 is right here. Your x-intercepts will always be on the x-axis, so you can expect that one. Now our vertex is right in the middle of them, so to find our vertex, and we'll start with our axis of symmetry, we add our two x-intercepts together, 2 plus negative 2, and divide by 2. So 2 plus negative 2 is 0, divided by 2 is 0. So x equals 0 is my axis of symmetry, and I know my vertex is on that. So my vertex has an x value of 0. And to find the y, we're just going to plug 0 in here. So y equals 4 times the quantity 0 minus 2 times 0 plus 2. So y equals 4 times 0 minus 2 is negative 2 times 0 plus 2 is 2. So y equals 4 times negative 2 is negative 8. Negative 8 times 2 is negative 16. So that goes way, way down low. So I'm going to change the markings on here. I'm going to go by 3, negative 3, negative 6, negative 9, negative 12, negative 15. That will change this up here to positive 3. This would be positive 6, positive 9. But my x-axis is still going by 1, so I'm not going to change those numbers. So 0, negative 16 is my vertex, and that's going to be way down here. Okay, so I've got my 3 points. Draw my parabola in there as nicely as I possibly can. I still need to draw in, though, my axis of symmetry, because I always draw that in. You always need to draw that in on your graphs. So here's your axis of symmetry. That's the line x equals 0. All right, so there is our nice parabola. Let's do one final type of example problem here. In our final example, it says you'll be asked to change from intercept form and vertex form into standard form. So if you notice standard form, if you flip back and look at the previous page, there's no parentheses in there. So really what we need to do is multiply and distribute. So I'll start by giving this 3 times x and 3 times negative 4. 3 times x, so y equals 3 times x is 3x. 3 times negative 4 is minus 12. I'll keep my parentheses there. And I still have to multiply that by x plus 6. So 3x times x, keep my y equals, that's 3x squared. 3x times a positive 6 is plus 18x. Negative 12 times x is negative 12x. Negative 12 times 6 is negative 72. And combine our like terms. These are our only two like terms. So it's y equals 3x squared. 18 minus 12 is plus 6x, and then minus 72. So this would be in standard form. So we just switched it from intercept form into standard form. Now let's switch this next one from vertex form into standard form. And the key thing here is that we've got a squared sign right here. So that means x plus 4 times x plus 4. So we've got to multiply that together. We can't forget about that. So this is really negative 1/2 times x plus 4 times x plus 4 plus 5. And that's f of x equals that. So let's multiply here. Let's use FOIL, first outside, inside, last. So we have x squared plus x times 4 is 4x. 4 times x is plus 4x again. 4 times 4 is plus 16. I've got this in parentheses because I've still got that negative 1/2 out there. Still got that f of x hanging out in the front as well. Draw a line to separate these two. We still got plus 5 hanging out at the end there as well. And so let's simplify this a little bit. F of x equals, I've still got that negative 1/2. Let's simplify inside parentheses. So I've got x squared plus 4x is 8x plus 16, and then plus 5. Now I need to get rid of those parentheses, and I do that by multiplying that negative 1/2 times all the pieces inside. So f of x equals, I'm going to move this up a little bit just in case. Let's getting a little low on some of your computers. So f of x equals negative 1/2 x squared. Negative 1/2 times 8 is negative 4x. Negative 1/2 times 16 is minus 8. And I still have plus 5. So my final answer, f of x equals negative 1/2 x squared minus 4x, and then negative 8 plus 5 is minus 3. All right, so that is all for this lesson. Make sure if there are any examples that didn't make sense, you star them so that we can talk about them in class tomorrow, and have a wonderful night.